Hello everyone, welcome to Form 3 Mathematics, Chapter 5 Trigonometric Ratios, Exercise 1, which is based on the Part 1 video. So before we start, you can find the link to this exercise in the Word file provided in the description below. So I would recommend you to download the exercise and print and complete the exercise before you watch this video. And you can do the exercise while watching my part 1 video for guidance. So we start off with the question number 1. Identify the opposite side, adjacent side, and hypotenuse based on the given angle for each of the triangle. So given the triangle ABC, and given the reference angle here, which is the angle ABC, so we want to identify the opposite side for this angle. So the opposite side will be this side because this side is opposite to this angle. So the name for this side is AC. And for the adjacent side is the side which is beside this angle. So we take BC as the adjacent side. And hypotenuse is the side which is opposite to the right angle. This side AB here is opposite to the right angle, which is hypotenuse. B, the given angle here is the angle X. So the opposite side will be the side opposite to this angle, which is this side, which is PQ. And then the adjacent will be RQ, not RP, because RP, which is opposite to the right angle here, is hypotenuse. Next, you are given another right angle triangle. And for this angle here, even though it's using a different symbol, we call this symbol theta, which represents certain angles. So for this angle, the opposite side will be this side, which is Y, Z or ZY. And then the adjacent would be XZ. And the longest side, or the side which is opposite to the right angle, is the hypotenuse, which is XY. Now we have two triangles joined together to form ABCDE. So the first given reference angle here is EBA. EBA. So we look at the center here is B, hence the angle is located here. And for this angle, we only look at this triangle ABE. We only refer to this triangle. We ignore the lower triangle for now. So for this angle, the opposite side will be AE. The adjacent side will be BE or EB here. Okay, it doesn't matter you write EB or BE. And of course, the hypotenuse is the longer side, which is opposite to the right angle, which is AB. Now for the second angle, ECD, the second angle will be this angle here. And for this angle, it only refers to the second triangle, the lower triangle. So we ignore this, the upper triangle. So for this triangle, the opposite side for this angle here is ED. And the adjacent is EC, while the hypotenuse is the side which is opposite to the right angle. This is right angle, DC. Question number 2. Complete each of the following below based on a given diagram. So you are given this diagram, PQR, right angle triangle, and you're given angle X and angle Y. We need to find sine X, which only refers to this angle X. So we ignore Y for now. So according to the formula, sine X, or sine of a reference angle, the acute angle here, equals to the opposite side over hypotenuse. So sine X. So the opposite side for this angle is PQ. And the hypotenuse is the side opposite to the right angle, opposite. Yeah, so it's opposite side is PQ, hypotenuse is PR. So PQ over PR is the answer. PQ over PR. Whereas cosine X has the formula cosine X equals to adjacent side over hypotenuse. For this angle, the adjacent will be RQ. Hypotenuse is still PR. So it's RQ over PR or RP. The last one, the tangent X. The formula is tangent X equals to opposite side over adjacent side. So for this side, the opposite is PQ and the adjacent is RQ. So it's PQ over RQ or QR is the same. So now we're still using the same diagram, but we are now looking at angle Y. The reference angle is Y now. So we refer to the formula. Okay, even though the formula here written X, but X can be any reference angle that we are using. So in this case, X here is actually the Y for this angle. Okay, so we consider this as sine Y. So sine for this angle is opposite side over hypotenuse. So the opposite for this is QR or RQ here. Hypotenuse is still the same, PR. So it's QR over RP. For cosine Y, here cosine is adjacent side over hypotenuse. So the cosine is so adjacent side is this PQ, hypotenuse is RP. So PQ over RP. And the last one, tangent X, or the tangent for this case is Y equals to opposite side over adjacent side. Opposite side for this angle Y is RQ. Adjacent is PQ. So the answer is RQ over PQ. Now we go to question B with a different diagram now. Again, this diagram has two triangles. And if you want to refer to the angle X here, we only look at this triangle, the left triangle, which is triangle MOP. We ignore the right hand side triangle for now. So for sine X, use the formula opposite side over hypotenuse. For this angle, the opposite side, since we ignore this, for this angle, the opposite side will be this opposite. So it's MO or OM. Hypotenuse is the side which is opposite to the right angle for this triangle. Okay, so it's MP. So opposite side is MO over MP. Cosine X is adjacent side over hypotenuse, so the adjacent will be PO or OP here over hypotenuse, which is still MP. So OP over MP. And lastly, tangent X, opposite side over adjacent side. Opposite side is MO, adjacent side is OP. So MO over OP. Now we look at Y. For angle Y, we only look at the right hand side triangle, the right triangle. We ignore this triangle, the left triangle. So this triangle here is also a right angle triangle. So for this Y, so for this angle Y, sine of that angle Y equals to opposite side over hypotenuse. So opposite side is ON, hypotenuse is MN. So ON or NO over MN. For cosine, adjacent side over hypotenuse, so adjacent will be MO, this one will be adjacent, hypotenuse is MN, MO over MN. And lastly, tangent X or tangent Y here, it's opposite side, which is NO over adjacent, which is MO, NO over MO. Question 3. Diagram shows a right angle triangle ABC. Calculate the value of A, the length of AC, because the length of AC is not given. Then you find sine, cosine, and tangent for the angles. So notice here the angles are different, but we look at that later on. We find the length of AC first. Since this is a right angle triangle, we can always use Pythagoras theorem to find the sides. So AC is the hypotenuse, means AC squared equals to AB squared plus BC squared. This one you learn in Form 1. So we fill in the values. AB is 4 centimeters, BC is 3. If you calculate this, you get 25. And in order to find AC, you need to find the square root of 25, which is 5. Means AC now is 5 centimeters. So now we have all the values of the sides ready. We find the angle of sine angle BAC. So since A is in the middle here, so the angle is here. This is the angle. And to find the sine for this angle, we use the formula opposite side over hypotenuse. So for this angle, the opposite side will be here. This is the opposite side, BC. So we take the 3 here, and her hypotenuse is this. This is the hypotenuse. So it's 3 over 5. So it's 3 over 5. Now for the second one, the cosine of the same angle, BAC, so you're still using the same angle here. Cosine, the formula is adjacent side over hypotenuse. So the adjacent side for this will be this, which is 4. And it's over hypotenuse. This is the hypotenuse here, it's 5. So it's 4 over 5. So the answer is 4 over 5. And for the last one, the tangent, the angle now is different because it's BCA. C is in the middle. So now we are looking at this angle, BCA. And to find the tangent, we use the formula opposite side over adjacent. So the opposite side to this angle is this. This is the opposite. Yeah, hence it's 4. So here is 4. And the adjacent side is 3. So it's 4 over 3. 4 over 3. Question number 4. Diagram shows the right angle triangle ABC. Again, it's similar. Now we have this triangle here, PQR, right angle triangle, and one of the length of the side is not given. Okay, so the first thing we need to find the length of PQ, then we find the trigonometric ratios for the angles. Now, length of PQ here. So again, since it's a right angle triangle, we use Pythagoras theorem, but the hypotenuse is given, so it's QR squared equals to PQ squared plus PR squared. And then we fill in the values. QR is 10, PQ, we don't know the values, and PR is 6. Then solve this, we move the 6 to the other side. 10 squared is 100 minus 36. You get 64. To find PQ, we need to find the square root of 64. And you get this is 8. So we know that PQ is 8 centimeter. Now, since we know all the values for the sides, we look at to find the sine for angle PRQ. So R is in the middle, so we are now referring to this angle PRQ. So this angle, to find the sine, we need to find the opposite side, which is this. This is the opposite. Yeah, so it's 8 over hypotenuse. So hypotenuse is 10. So it's 8 over 10, which can be simplified. Must be simplified if it can be simplified. So it's 4 over 5. And now for the next one, cosine PQR. PQRQ is in the middle, so now the angle is here. Okay, so to find the cosine, adjacent side over hypotenuse. So the adjacent of this angle, adjacent side of this angle is 8, and the hypotenuse is 10 because hypotenuse, this side is opposite to the right angle triangle. So it's 8 over 10, which can be simplified to 4 over 5. For the last one, tangent QRP, again, R is in the middle, so now we return to this angle again. To find tangent, we find the opposite side over adjacent. So this is the opposite side again, so 8 over adjacent, which is 6. So 8 over 6, simplified, you get 4 over 3. So this concludes our video for exercise 1. I'll see you in the part 2 video for trigonometric ratios. Thank you.